2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome out there on one of our specialized segments today. We always love doing these things because it gives us a chance to go in depth on some great topics, algebra, geometry, all sorts of good things. But you know what? I'm Ernie Roberts and I am your host this afternoon. Now on specialized segments days, we don't have the phones running, but we do still have our Facebook and our Twitter up and running, and we'd love for you to send us questions on it. We'll answer that on our live shows next week, all right? But in the meantime, we want you to sit back, relax. Today you may want to get some graphing paper along with pencil and even a graphing calculator if you've got one close by. If you don't, hey, we've got one to supply for you here. And just watch and see what you can learn from us today. All right, sit back, relax. Let's do some math. And let's see what that topic is, where we're going. Ooh, a big one here. Where's the vertex? Where's the vertex? You know, there used to be a commercial called Where's the Beef? This is Where's the Vertex, all right? But it's how we have to make the rest of our graphing for parabolas work. Once we find the vertex, life is good. Life is good. And there's a quick and easy, painless formula for it. And we're going to go through that here in just a second, all right? But anyway, once again, thank you for tuning in today. Get those graphing calculators, get that graph paper ready. Even if you don't have graph paper, use your lined paper. It'll work fine, all right? But let's do some math. All right, let's see what our first problem is for today. We've got a graphing, and this is quadratics today, folks. Remember, a quadratic has x squared involved with it. And when we look at a quadratic equation, just to give you a quick review, if we have ax squared plus bx plus our c, and our y is equal to this, this tells me this is the coefficient right up there next to x squared. Notice here it's a 1/2. You say, Ernie, I don't see a b, I don't see an x. You're right. So b in this case is going to equal 0. If we don't have a certain term in there, the quadratic formula, quadratic coefficient would be 0. In this case, there is no x going there, all right? Formula is another game. And then our c is the number hung on there at the end. In this case, it would be -1 or -1, all right? So we've got an A, we've got a C going for us. We just don't know what B is, but you know what? We do know what it is. It's 0. It's 0. So we're going to use 0, and we're going to work from there. Now, there is a formula for the vertex. There is a formula for the vertex, and it is opposite of B over 2A. Now, let me put it down here, what we got here. First, we're working today, our first graph is y equals 1/2 of x squared minus 1. And remember what I said, we've got A equaling to 1/2. We have our B hanging in at 0. And good old C is sitting on -1. Now, the formula for finding the vertex, and you say, how do you find the vertex? It's the bottom or the top of the graph. Now, if it's opening upward, it's going to be the minimum. It's going to be the bottom of your graph. It's going to be your bottommost point, all right? If it is opening downward, that means it's going to be at the top of the graph, which is the maximum point. And again, as it goes downward, it's going to be a coordinate, though. So it means we have to have an x and a y. X and a y. So here's the first part of it. Here's the first part of what we're going to look at. The x formula equals the opposite, and I've used that very importantly, opposite of B, all over 2A. That is the magic moment, because that gets us the x value. You say, well, Ernie, what about the y? Is there a formula for that? Right there is the formula for y. Whatever we get for x, we push it right in there, and we have our y value, and we have the beginning of our graph. We have the highest point or the lowest point, depending on whether it's opening up or opening down, all right? So that's going to be the storyline today. Now, we've learned a few hints along the way to take care of things, all right? So, let's go back and look at our little graph here just a second, the one I've got here, and then we're going to go to the graphing calculator. But what we want to notice here, first of all, is this 1/2 tells a lot of information, folks. That 1/2, first of all, says it's positive, it's opening upward. The graph is going to open upward. It's also less than 1. Its absolute value is less than 1. So it means it's going to be a little bit slower. It means it's going to be a wider parabola, all right? I say it opens up slowly because it takes a little more time when it has to cover more distance because it's going through that 1/2 motion, all right? This tells me where it's going to bottom out. This is telling me it's going to go down -1. Remember, this number out here by itself is saying it's going to shift some up or down, all right? Now you said, what about left or right? In this case, we're not too worried about it. Remember, our parent parabola comes right up here, and we're going to look and see how this one looks. So let's take a look at it on the graphing calculator. All right, guys, take me over there. Once again, folks, how do we get there? We go to y equals, that key right up there in the corner as I'm pointing. Follow my cursor a little bit. I got something else in there. Let's clear that out. We really don't need that. By the way, it's easy to clear these things once you've got something in there. Let's do, our function is 1 divided by 2. That's how we write a fraction. 1/2 is just simply 1 divided by 2. Some of y'all might want to use the decimal in a 5 or 0.5 or 5/10, however you want to read that. And then here we go. We've got x running around. Let's see if I can get my cursor to go there. There he goes. And we're going to square. There's a little x squared button right there. Don't ever press that by itself. It'll just give you a strange exponent with nothing attached. But I've got the x. We'll put the 2 right there, and it's happy. All right. By the way, there it is. You see that? So that's our expression. That's 1/2 x squared. Now, we also need to subtract. So hit the subtract button, by the way. That is on the right side of the calculator, not down at the bottom, but on the right side. There's the subtract symbol. Be sure you use the right thing, otherwise you're going to get an error flashed at you and say, fix me. And we'll put a -1 right there, all right? Let's see what this looks like. This graph, I've kind of told you it's going to be rather wide. It's going to open upward. It's also going to be hovering around y equals -1. Let's see how accurate I was in all that statement for you. Let's hit graph. It's up there somewhere. There it is, graph right up in the corner. And there's our graph. Here it goes. There it goes. There it goes. Now, I'm going to try to make us a table on the other page here, but while we're at it, let's keep our function up here. Let's keep the graphing function up here. And let's trace. Let's trace. That's the way we do it. Notice it took us right to 0, -1. Also, my dear friends, that is the bottom of our graph. That is the bottom of our graph, all right? Now, since I've got a 1/2 running the show here, and it really does run the show, I need to put numbers in there that when I square them, they're going to be divisible. I can make some fractions, but it's a lot easier when we're plotting. So let's go for 2. We've got the trace button going. So remember, all you have to do is press 2, and it all of a sudden pops up down there in the left bottom corner. You see that, everybody? Let's press enter button, and let's see where that's going to take us. It's going to take us to 2, +2, 1. So I took it to the right this time. Sometimes I take it to the left, sometimes I take it to the right. Let's go ahead and move to 4. 4 is going to get us way up there. It might be off the chart I've got for my little graph. But let's see what happens when we get 4. And we're going to have 7. It's going to be real close to being off the chart for my graph. So there we go. Now, let's go back to my graphing paper here. We got 3 values here. Maybe we don't. I need to push it up just a little bit for you guys. There we go. All right, we got 0, 2, 4, and -1, 1, and 7. All right, just write those down. Remember those. Those are our values that we're going to plot here in just a second. All right. Now, above that, remember what I told you the other days? Because parabolas are so beautifully and symmetric, we can put a -2 right there, and we know it's going to go to 1. And we can put a -4 right here, and we know it's going to go to 7. That's the beauty of when things get squared. And by the way, what happens when we put that 4 or -4, either one in there? It squares that value, then takes half. All right, be careful. Don't take half of the number, then square it. Remember, good old Aunt Sally and the order of operations. So let's plot these guys, all right? We've got 0, -1. I know that's right in the center. I've also got -2, up 1. So right there we go. That's its point. And then we got -4. And we're going to go 2, 4, 6, 1 notch up, all right? So there's our left side. Our right side is going to be symmetric to that. So we're going to kick over to 2, and we're going to be at +1 again. We're going to kick over to 4, and we're going to be up to 7. Try to get up there pretty close. Your graph paper at home probably makes a lot better moments than this. So here we go. Let's pull it up. There it goes, curving up. And it's going to be tight. And this one comes up, and it's a little bit wider than our typical ones, all right? But when we bring it up here, it starts to get a little bit tighter, because the parabola tightens up as it goes up higher, because the numbers are increasing rather fast. That's squaring effect, all right? But that's what it looks like. There it is. There's your, what we call the vertex, and it is at 0. We'll do 0, blacked in 0, and -1. There we go. How pretty that is, all right? But that is our story. -1 is our vertex with the y value. 0 is the x. Now you say, Ernie, how did that get to be -b/a? Because we see what happened here, all right? Let's see how that worked, all right? Or the opposite of b/a, as I like to say, all right? Y'all got me on that? Opposite of 0 is just 0, all right? So it's going on top. Underneath, my a value, in this case, is 1/2. So it's going to be 2 times 1/2. And what do you get? I get 0 over 1, which simply equals 0. So there you go. X coordinate equals 0. We also found the y already, because we've already done that, is -1. So your vertex is 0, -1. That's how we get to that. That's how we get to the vertex. Simply find x, check out y. Now, it was real easy to look at this graph, but sometimes the vertex doesn't land on the y-axis. This time it did, all right? And that's when we have to go, oh boy, things are a little bit different. We watch out where we're going. And that's where we're going to go today, all right? So stay with us on that. We're going to pick up a few more exactly lovely values. Let's take a look at our next problem. It says we're going to graph. Of course we're going to graph. We're doing graphing all day long, aren't we, today? We're going to graph this value, y equals -2x squared plus 4. Now, first of all, let's just look at that and think if we can get a picture before I hit you on the graphing calculator. Now, first things first, you know what? That -2 tells us something. It tells us it's going to open downward. It's going to open downward. And if we look at the value 2, not with the negative attached, but the absolute value of this -2, which is 2, that also tells me it's going to be rather narrow compared to our normal size parabola, because it's going to open up very quickly, and it's going to open down actually very quickly here, all right? But when your graph starts beginning to take its shape, it's going to be very quick, all right, and make it narrow. This plus 4 tells me 4 on the y-axis, all right? Let's see, clear this last graph we had out of here, and let's put in our new one here, all right? New graphing calculator moment here. How about it? 2x, and we'll put a squared on that. And we have a negative in front of it, do we not? Let's try that again. Let me clear that out, and we'll put a negative in first. Put our negative, remember, it's down there at the bottom. Got to go there when you put the first number in. We've got 2, and then we're going to put in our x, there it is, x, and square it. All right, y'all got that at home? We're going to add 4. We're going to add 4. Again, that -2 opens it in a downward fashion, all right? Let's see how good I was at predicting this. I hope it does. Let's check it out, folks. There we go, and there it is. Beautiful. Opens downward, rather narrow compared to the last one. Last one we had was rather slow opening upward, all right? But opposite directions, remember, that's what happens when we put bigger numbers on the x squared. It opens faster, whichever direction it's going to go, all right? And let's trace and see what's happening there. It takes us right to the center where we want to start. So let's see how that's going to work. Let me make the table over here while you all are watching on the graphing calculator. Let's see what we've got here. We got 0 and 4. And you know what? Let's trace a little bit. This is one we don't worry about numbers like 2 and 4. We just go 1, 2 because we're going to have whole numbers involved. That's the reason why we worry about those things. So let's try the positive side. Why not? Let's go with 1 and let's enter. And that gives me 1 and 2. I'm going to also pick up. And you see, also, that's a great thing about the graphing calculator. It shows you where you're going with it. Let's put in a 2 and see what happens when we put in 2. It's going to move down pretty quickly. Remember, I told you this was going to open up going to be speedy. It's going to be narrow, which means it opens up very quickly. And we're already at -4, and we're roaring right on down the panels. Okay, there we go. Now, how about it? Let's see. We also have, on the other side, the negatives. Well, it's symmetric. So it should work out. Let's go ahead and put those numbers in there with our negative values. I'm kind of reversing them this time. Let's see what happens if we have -1 and we have a -2. That means we're going to go to the left. Now remember, when we plug this thing in, once we find our vertex, by the way, you say that's the vertex, we'll experiment with it. We'll use the formula, but there it is. That's where it's going to be, because you can see that on the graph pretty easily on this one. Worked out very nicely. But let's see how we're going to go on this. We're going to plot these points. By the way, this is going to be a 2, and that's going to become -4, all right, because we're going to have this thing going into the reverse order. So here we go. Let's put it there. We start that vertex. I always like to go there if I can. Right there is 0, 4. Just don't leave out your other points. We're going to go over 1 and up 2. Remember, this thing is opening downward, and it's moving downward very quickly, all right? Then we're going to go to 2, and boy, already, like I said, we're down to -4. So see how quickly this thing is dropping, all right? Very fast, very fast. Beautiful little parabola here. Over here, we pick up the same points. Remember, they're mirror images. This is what we call the axis of symmetry, which in this case is x equals 0, also known as the y-axis, all right? And here we go. We got also a -2, -4 moment coming right at you here. So let's bring it down. Again, by my formula, opposite b over 2a. Well, folks, in this case, let's start over again. How about it? We have -2x squared. I'll get it out. Plus 4. Again, our a is -2. C is 4. We have no b, so we call it 0. All right? So here we go. We got 0. This time over 2 times -2. Now remember, it really doesn't matter what's underneath, although we have a -4. When we have 0 over that, our x value, in this case, this is what our x equals. Our x is equal to 0. All right? When we put a 0 in there, we come up with 4. So the vertex is at 0, 4. Well, look at that. There it is. There's our vertex right there on the top. Our axis of symmetry is what divides this graph into a beautiful half and half. All right? Left side, right side look identical. It's parabolas. That's your parabolas. In fact, doesn't it, you know what that looks like? It kind of looks like that Gateway Arch out there in St. Louis, all right? So you always wonder, when do we use these things? There's your good example right there, all right? So thus far, we've had the vertex sitting there on the y-axis. What happens when b actually takes on a value? Let's check it out here and see what's happening. Let's take a look at our next one here. We've got x squared minus 4x. Now I'm going to go ahead and move this one out of the way, and let's see if I can clear off the graphing calculator here. And we're going to check and see how this one behaves, all right? Hang on just a second. Clear that one out. All right, let's put in our next one here. It's going to be x squared, and we're going to subtract 4x. And again, this time, notice I don't have anything tacked on to the end. I don't have anything tacked on to the very end. However, when I look at this, y equals x squared minus 4x, I'm noticing that I have a b value this time. So I am going to use a little more algebra here. I'm not going to say, oh, it's going to be at 0 and that makes it easy, all right? We're going to let a equal 1 and b equals to -4. This time c equals 0. But if you'll remember, c really doesn't have a lot to do with the vertex until we plug in the formula that we have here that you're looking at, all right? So let's take a look at how this graphs. And here we go. Notice this time we shifted. We finally got off that y-axis there, all right? But we're going to cross it as an intercept, but our vertex is no longer there, all right? Our vertex looks like it's shifted over to around 2, a +2. So let's take a look at how this one works out here. Let's map this out. Let's work it out algebraically here, all right? We've got y equals x squared minus 4x, all right? And I want to go ahead and say that a is 1, b is -4. Let's put it in the formula and see what comes out, all right? Here we go. We got x equals the opposite of b all over 2a, all right? And let's see what happens when we do that. The opposite of -4. That's why we don't just call that -b. We call it the opposite because we got to change the sign. And that's going to make it positive, all right? And here we're going to put in 1 for a. So that's like saying over 2. So guess what? X is equal to 2, just like I promised you it would be. Yes, all right? So we're going to set up our table here. This will be our x. This will be our y. Oh, some of you said, we saw f of x up there. You know what? F of x and y basically are the nice fancy, f of x is a nice fancy way of saying y, but we're still going to be graphing with x and y axis, okay? So you can just pretend that's f of x there, all right? But anyway, let's see what's happening. We got 2 for our middle point this time. And so we're going to go back. Let's trace a few of these, all right? See what happens. We have trace on the graph. And I want to see and by the way, notice it took me to 0, 0, which tells me there is a point that's going to be at 0, 0, all right? And it makes sense because if you put a 0 in those two x's, you're going to get 0 for y. But let's see what happens with the trace of, how about it? Let's go to 1. See what happens with 1. And 1 gives us -3, all right? We never got to what the actual vertex was, did we? Well, let's go ahead and put 1 and 3. But it looks like 2 is going to be our vertex. Let's check and see if this goes to bottom out here. Put 2 in. Ah, there it is. So it's 2, -4. And we already saw that 0 is going to give us 0. So let's bring it back to our actual graph here. And see what we can do. We have 0, 0, we have 1, 3, and we have 2, negative 4. Now, friends, here is the vertex, and this is where you got to be a little more careful, all right? This is the center, so no longer am I going 0, negative 1, negative 2. I've got to have 2 as my middle number here. Then I'm going to put a 3 and a 4 right down there. Those are the points I'm going to try. Then remember, it's symmetric. So 2 and negative 4 is the middle. That is the axis of symmetry is going to go right through x equals 2. That's the idea, right straight up and down. So here we go to the left. So to the right is doing the same thing. So we're going to get 3, 3, and we're going to get a 4 working with 0. All right, 4 working with 0. So let's see where this is going. Again, let me check out one more thing. I want to make sure here. Yep, it is a negative 3, folks. There is a negative there, I just didn't see it. So we want to make that a negative 3, all right? Otherwise, we'll have some funky points there, all right? So again, when you're transcribing your trace, be sure you're filling in your tables correctly. So let's go ahead and graph this thing now. Back to my graphing page here. Thank you, guys. And here we go. Here we go. At 0, 0, there's a point. Over 1, down 3, there's another point. Wow. Over 2, down 4. There we're at negative 4. All right. Then we've got the 3 going over negative 3. And then we got our 4 finally back up to 0. You see, look how those points are just great. They look just like a parabola. Well, they will be once we pour something through them there. So here we go. Great. Here we go. Something like that. Opening upward. Very nice. Very nice. Notice this time our axis of symmetry is at x equals 2. Axis of symmetry, that's that vertical line that splits this thing into half beautifully. Axis of symmetry at negative 2. The vertex is at 2, negative 4. Remember, we substituted in here. We said y equals 2 squared minus 4 times 2. That's where we got negative 4. So see, there's the y that goes with this x. Therefore, we get the point 2, negative 4. That's your vertex. Now, notice what's going on. It's opening upward, so it's a minimum. It's the lowest point on the graph. It's the minimum. How do I know it's going to open up? Positive x squared. And I knew it wasn't going to be at 0 because I have a value for b. Anytime you get a value for b, it's going to shift it somewhere to the left or to the right. It's going to all depend on what number is next to the x squared and also what number is next to x. But if it's not 0, it's moving. It's moving. Let's take one more here real quick and got this one here. Go back to y equals x squared plus 4x, plus 4. This one has all sorts of fun and games with us. Take a look at that. Let's see what's going to happen, see if we can figure out real quickly how we're going to deal with that. We're going to have, first of all, we're going to have x squared being positive, so let's pop it in there, x squared. And we're going to put plus 4x. And we're going to add plus 4. Now, before I press the magic button and graph it, I want us to think about it. A is 1, B is 4, and C is 4. So this tells me already this is going to be a normal-looking parabola. Hey, a normal-looking parabola. What an idea. A is 1, B is 4. It's going to be upward, and it looks like the vertex is not going to be on the y-axis. So let's see actually where it goes. Let me hit the graph button real quick. And there she goes. Oh, it looks kind of like it dead-ended into the x-axis down there, all right? So we're going to play that out, hit a trace, and we'll figure it looks like it's going to 0, 4 for one of our points. But we want to go through the vertex process. So remember, A is 1, B equals 4, and C equals 4. So let's go back to my paper here again and see where we're going to go. We're going to try to figure out what is x equal to. X, remember, equals the opposite of b over 2a. And in this case, b is going to be a negative 4 when we punch in the opposite, because b is actually 4, over 2. So we're looking at negative 2 for x. So hit a trace real quick. Trace gives us a negative 2. Folks, our vertex is at negative 2, 0. So we're going to put that right in the middle. Now we're going to go back to negative 1 and 0. That's going to the right. Okay, and to the left we're going to negative 3 and negative 4. Let's put a negative 1 in there on our tracer. I'm going to do that real quick for us here. We get positive 1. Put a 0 in there. Looks like we're going to get 4. We went there to begin with, but let's make sure. We got 0, 4. Coming back through, remember it's symmetric. So we're going to have 1 and a 4 here, it looks like. Let's plot those points. Let's plot those points, see what's going to happen. We've got 0, 4, right there you go. We got -1, 1. We've got -2, 0. We've got -3, 1. And we've got 4. 4 here. Let's count them right here. Sorry, guys. Right there we go. Let's run it right up through there. There's our current value. Now we go here. That one is not, that does not need to be there. Notice that. There's our parabola. Axis of symmetry at x equals -2. Again, it's all about the ABCs, all right? And where's the vertex? Opposite b over 2a for x, then find your y. Hey, find us next week here live on Mathline. See you then.